All right. So with that, I want to sort of shift focus on, moving into AI. So the goal of this podcast for me has always been when I got into the field, which was only 3 years ago, pretty much at this point, getting into it 3 years ago and going, oh, this actually looks like it's about kind of where cloud computing was 13 years ago when S3 launched and Amazon started developing Amazon Web Services. I feel like this is now the sort of implementation phase. We're actually putting stuff into production. It's doing real work. And so, as we get into that, I think an interesting question to sort of help people who don't really know the space is just like, where are we? What does the next 10 years look like? What can it do now? And what will it be able to do in 10 years? I know it's a broad question, but I think just helping give people a grounding who really don't know the space and really don't know the state of the art. And I think what you're touching on with the protein folding, for example, which is like doing very complex analysis for proteins, which we couldn't do before and now we can do, right? That's a good example of that. What else do you see that's kind of on the horizon? We can see it pretty clearly in the next 5 to 10 years. And where
I mean,
are we in that arc?
we're definitely at a tipping point. Look, if you don't know the history of AI, you know that for 50 years it didn't do much, right? And it's not theoretical physics. You can't just write down the math and go, well, we promise it'll work in some way out in the universe, right? It's a practical field. It has to do things, right? In real life, it has to spot digits or understand language or pick objects out of an image or whatever it is you want to do with it,
Right.
right? And the fact is, we had the theory for many years. All those books, that you're talking about. I had all these old papers with, perceptrons and all this,
Yeah.
and Lisp, and thinking like, yeah, it's amazing. And like you said, it didn't go anywhere. So I went to, IT, right? IT consulting company for many years, and then then all of a sudden, like you have this thing where it's the main problem is they just didn't have the processing power. They didn't have the data sets. Right.
Right.
And then all of a sudden you have the rise that you want to talk about the interaction of systems and how systems put pressure on things. All of a sudden you have this kind of thing that changes something. Like when you get the printing press, all of a sudden, the Greek classics come out of like antiquity. They come out of the 5 copies that are sitting in a monk's cave somewhere. And now all of a sudden they're getting printed and people are reading them and going, whoa, this is mind blowing. Changes my thinking on things. Let's all of a sudden, all this stuff you couldn't print before because it was super controlled and required a lot of effort to do. All of a sudden, now you're printing all kinds of stuff and
Right.
you're accelerating knowledge. So the same kind of thing here when the internet comes out, all of a sudden you start getting these huge data sets. That's number one, right? Internet scale data sets. And the second thing is you get these graphics chips, right? Which, like with the rise of video games, everyone thought it was kid stuff. Well, who's laughing now, right? And you look at it and like it's all these little chips that are basically processing in parallel, which turns out to be awesome for matrix math. And you have kind of the seminal tipping point, which is, AlexNet in 2012, right? Where they basically, a student of Jeffrey Hinton. And remember, before this, Jeffrey Hinton and a few others are trying to keep the lights on with like one grant from the Canadians, right?
Right.
For a decade when everyone's telling them it's nonsense and it's not going to work, right? So they keep the lights on. And all of a sudden, one of his students does AlexNet and object recognition dropped from 30% error rate to 15% with AlexNet. The next year, everyone's using neural nets. It drops to 7%. 2 years later, they close the contest because it's better than human beings, right?
And for those who are not familiar with AlexNet, that was everyone refers to that as like the ImageNet moment in computer vision, right? So this was using deep learning and deep neural networks for them to identify cat images, right? That was fundamentally the whole data set that I think Fei Li was one of the founders of that whole setup, right?
It was more than cat images. Yeah, Fei Li was the founder at Stanford, and there's 1,000 different objects that you have to recognize in the original ImageNet. And they were, AlexNet was one of the first sort of breakthroughs in that point and said, hey, this can actually work, right?
So, and that was around 2012, right? And that was the first big sort of like the big moment for deep learning, because as you said, Hinton and all the folks who were pushing on it for decades, everyone's like, this is nice theory, but it's not going to work in reality until the compute and storage capability was there, and suddenly it made sense.
Right, and now we've had kind of like a rapid evolution in the last 10 years. You've had all those folks getting plucked out of academia and $1 million jobs and moved into big tech. You've got and you've got these kind of internet scale companies where they basically can't Facebook, for instance, can't track all of the different images. You can't hire 300,000 people to look at every image that's posted. You need artificial intelligence to do it. Again, there's certain problems.
Comes back to scale, right?
Comes back to scale, right? And or you look at they had Neural Translate was at Google, where essentially like they built a rule-based system that was pretty good. Like you could put in some standard phrases and you're welcome and good luck and get those kinds of things with 100% accuracy. But go put it in Hemingway text and try to get something coherent out the other side, and it's like, not so much, right? Whereas all of a sudden, Neural Translate takes it to this incredible new level where they're basically they're basically using encoder and decoder, and they're taking all these pre-translated text, usually from a data set from the UN, right, where they have professional translators doing it. The neural net's studying both sides of it, and all of a sudden now is making the language sound much more natural. Now all of a sudden you have these real world applications that are happening. The thing is, though, it's still very early in the space. Most of the technologies sit in the big FANG companies. It's been in the military. It's been in governments, right? In China, it's been like awesome at productionizing it, mostly for city level things and facial recognition. I just went to the airport for the first time. I hadn't been back to the States in a few years. And global entry, I used to have to type in a few things and answer a few questions, and now it just says put your face in there, and it goes, here's your sheet, Mr. Jeffries.
Right.
Like, okay, so apparently I'm in the facial recognition database.
Yeah. But I see that as kind of two waves, right? We've got that 2012 wave that comes through, which is around kind of image processing, let's say, and deep neural networks for image processing. And now we see this whole wave of natural language processing, right? All the GPT-3s and all the equivalents and the global equivalents in China. There are competitors to that. They're apparently even bigger. So this new wave coming through of language and translation, and that's now pushing through the system, as you would say.
Yep. But we're still in the early adopter phase, and like we've got to come down. If we look at that curve, that kind of diffusion of innovation curve that's in that book, is a fantastic book. It's very scholarly, but kind of talks about what is innovation, ideas and technology, and how do they disseminate in a social network? In other words, how do they filter into society? What's the resistance that they face? Who's the most likely to adopt it first? Why? And who adopts it late? We're still in that early adopter phase. So we're out of the pioneering stage, but we're in the early adopter phase where it hasn't trickled down to every single business. It's still at the point where it's like the iPhone 1, right? But you try to explain the iPhone 1 to someone when you get it, and people can't imagine Spotify and what Instagram is, and all the things that are coming. You're going to be able to listen to music anywhere, and you're going to share photos all the time, and you're going to chat with your friends and crypto. They're like, what? People, look at that. They're just not going to get it. The thing has to become ubiquitous enough with early adopters who understand what the pioneers did and start saying, look, let's start using it in this space, in this space. And there's a lot of failures. There's a lot of things that don't work out. And then the kind of naysayers are always come out of the woodwork at that point and go, well, the technology will always fail, And you're like, well, actually, like these 3 use cases are like amazing. And all of a sudden, it just takes off. And then you get to that early majority phase where everybody just uses it without even thinking about it, right? And we're going to, over the next 10 years, in 20 years, we're really going to get to is something where AI becomes much more ubiquitous in society, and AI itself is going to continue to develop over the course of that time into more general purpose and transfer learning systems, right? That's where a lot of the research is happening now. Right now, it's still very single purpose. You could train a machine to be the best Go player in the world, but then if you retrain that same neural net to like recognize cats, it'll forget everything it knows about Go. So there's a lot of research in saying like, how do we have multiple neural nets? One's a giant one and one's just a quick learner, and you freeze certain nodes in there to learn the old task, or you average them out so you only have the 5% of the ones, and you can continue to add tasks that it understands. These are the kinds of things that are going to develop over the next 10 years. But right now, it's already enough to have something that knows how to do something really, really well specifically. And we're going to start to see that disseminate out of the big tech companies into almost every company on the planet. It's going to touch every single society and type of business on Earth.